So this question right here may look like an ordinary giraffe question, but this is literally how fraud investigators reconstruct missing data. So let's solve it together. All right, so we have the question here on the screen, and it says that the stem and leaf diagram shows information about the height of 9 of these giraffes. So one giraffe has a height of 2.6 meters. No giraffe is shorter than 2.5 meters. And then the range of heights for the 15 giraffes is 2.3 meters. And more than 3 giraffes have the same height. And the modal height for the giraffes is 3.9 meters. So we have the leaf diagram here. And we have a key, very important key. It shows that 4 bar 1 represents a giraffe's height of 4.1 meters. So that means that this 2 bar 5 we have here means 2.5 meters, and then 3 bar 2 is 3.2, then bar 7 3.7, bar 7 3.7 again, and so on and so forth. So we are asked to use the information in the table to complete the stem and leaf diagram for the group of 15 giraffes. So the first thing we need to know is that the total number of giraffes is 15. Okay, so total number of giraffes is 15. All right, so far we have 9. That is 1 2 3 4 5 6 7 8 9. We have 9 giraffes. So let us use the information to find the remaining 6. So we have that one giraffe has a height of 2.6 cm. So this is one very crucial information. We have that one giraffe has a height of 2.6 cm. And if we look at our leaf diagram here, we don't have that giraffe here with 2.6 cm, but we have 2.5 here, so it's going to be among this group here. So that means we have one giraffe here, 2.6 cm. So we have gotten one giraffe, remaining 5. So let's look at the other information that we have. So we are told that no giraffe is shorter than 2.5 meters. So that is clear. So this is the lowest height we have, 2.5 meters. Okay. Then the next information says that the range of heights for the 15 giraffes is 2.3. Now, do you remember the formula for range? The formula for range is highest minus lowest, if you remember. So in this case, that is the highest height minus the lowest height. That is the range. But now the problem is this: we don't know if the highest height is missing. We are yet to find it. We don't know, but we can find it actually, because we know that the range is 2.3. So that means that 2.3 is equal to the highest, let's call it H, minus the lowest. We know that the lowest is 2.5, so 2.5. So what does that mean? This implies that the highest is actually 2.3 plus 2.5 meters. And when you add this all up, what we have is 4.8 meters. So the tallest giraffe here is 4.8 meters. So we have 8 here. So we have at least one 4.8 meter tall giraffe. We don't know if there are more than 2. Let's look at the other information to find out. So we're also told that more than 3 giraffes have the same height. Okay, more than 3 giraffes have the same height. So we have 3.7, 3.7 here, and we have 4.7. Well, let's see the next one. So the modal height for the giraffe is 3.9. Now, what do we mean by modal height? What does that mean? What does modal height means? It means the height with the highest frequency. That's what modal. Mean, mode, median, mean, mode, number, the number with the highest frequency. So it means that height is it occurs more than any other height in the data or in the data set. Yeah. So what we are told that the modal height for the giraffe is 3.9. So we have more 3.9s than any other. What does that mean? We have 3.2 here. We have 3.7, 3.7. That means that 3.9 is even higher than the highest that we have in the leaf diagram here. So that means we should have 1, 2, at least 3 3.9s should be here. So we have 1, 2, 3, 4, 5. So we have one more to settle, but we don't know what that is. So let us go back to this one. It says that more than 3 giraffes have the same height. More than 3 giraffes have the same height. So this should be it. It has to be 3.9, because we cannot say it is 3.7, because if we say it's 3.7, then 3.7 and 3.9 we have the same number of frequency. No, but we are told that the modal height is 3.9 already. So 3.9 has to be the modal height. And what else again? More than 3 giraffes had the same height. it can't be 2.5, it can't be 2.6 either. If we make it more than this, we have more than 15 giraffes. So the only height here that we meet with this condition is 3.9. So that means we have another 3.9 here, and boom. So we have our complete 6 giraffes remaining. So 1, 2, 3, 4, 5, 6. And we have completed the leaf diagram. Now, for those who will be saying, so what is the application of all this? It's just like what I said before the beginning of this video. One of the application is forensic information gathering, trying to put data or add missing data, put data together, reconstructing data. That is what it is used for. Okay. And another application of this is for when you want to recover data, for data analysts and data scientists. If you are doing or performing data recovery, you need this kind of thing. Maybe you have some information and you don't have other information. You use the information you have to get the information that you don't have. So for example, in data science, sometimes we may have missing variables in our table. Many times we fill in those missing variables with either the median or the mean. That's the average value. That kind of example. And then auditors also use this information to get gaps. That's to find missing. They use it to find missing or manipulated financial records. They use this kind of information to trace those kind of things. So these are the application of all this. So just like how I used to say in my other videos, see, there is no maths that you learn in school that does not have an application. It's just that we live in a country where we don't apply them, or we apply them and we don't know that we apply them. But mostly we don't apply them. And one of my hopes and dreams is that we will begin to put these things we learn in school into real life applications, because it's truly going to help us. So I hope you enjoyed today's math lesson, and I'll be seeing you in another video. Have a lovely day and goodbye.